Hello guys, my name is ISKANDAR, and today me and my team are going to give you guys a walkthrough about our system, which is hazard reporting system that called AWAS, and it is developed by using Android Studio, and it has a web server side. So let's begin.
So first, when you enter the system, it will welcome you with a welcome page. So you just enter, and then it will detect your location. All right, all right. So there's a about page here. So you can click about. So in the about page, you can see there's thing about our app and the copyright, the project repository, and this is our team. Right, so I'm inside the UITM. So as you can see, I'm here, and you can see in the mobile app, it's detected my precise location where I am at, and so there is it. And from that current location, we can report hazard that we have here. As you can see, this is on the road. So we report the hazard, and it will automatically detect your latitude and longitude. Right, so my name is Iskandar. Then hazard category is road hazard. Description. There is pile of wood and sticks on the road. Alright. Then we will submit the report. So alright, so the report successfully. Alright, so next we will go to the next location so that we can so that you guys can see the precise location of the system detection. Alright, so now we are inside the building, and as you can see here, there's a construction site here inside the building. Right, so as you can see in the mobile app, it will detect the location. Then we can report the hazard. Right, so now it's building hazard. Just put your name, then the description, construction ongoing. Be careful. So then we submit the report. Then it will show the building hazard, as you can see on the dashboard of the user. Building hazard, construction ongoing, be careful. Then we will go to the next location. So we are at our final location. As you can see here, there's a water leak, and you can classify it as a environmental hazard. It's just a scenario, so we just want to make to test the precise of the precision of the location detection. Right, so as you can see on the mobile app, it will detect your location. All right, so here we are, and we are reporting this. So my name is, then it's an environmental hazard. Water is everywhere. Use another road. Then we will submit the report. The report is submitted. Then you can see the submitted report. Environmental hazard. Water is everywhere. Use another road.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad AZMAN. Today I will be presenting about our mobile application project, which is awards. On the screen we can see there are two display, which is the mobile application and the web server. Before demonstrating the AMIR dashboard, I would like to briefly show how users submit a hazard report using the awards mobile application. So when clicking report hazard, so as we can see on the web server, the warning symbol been displayed. Okay, now I will continue about the AMIR dashboard. As we can see on the top right, there is a about button which display the purpose of awards, the hazard classification, the database use, and the system version. On the left, there is a light mode and dark mode button. On the top navigation bar, there is a total number of hazard. The first section is the total number of hazard, which is 5. The second one is the total number of road hazard, which is 2. The third one is the total number of environmental hazard, which is also 2. And the last one is the building hazard, which is 1. On the middle of the screen, we can see an interactive hazard map and the hazard symbol. On the right part is the hazard report detail. So as we can see, when I click on this symbol, it will display the hazard report detail, the description, the reporter name, the date and time of the report, the reported address, and the GPS coordinated, which is latitude and longitude. And lastly is the device and the environment used to report. The center on map view function is, as example, when I click on the symbol and the map is too far with the symbol, when I click center on the map, it will go straight to the symbol to ensure accuracy and where is the reported location. The administrator can edit the detail by clicking the symbol and click the edit report button, and the administrator can edit the description, the hazard category, the reporter name, and the GPS coordinated. After the changes have been made, the administrator can save change, and the administrator can also delete the report. As example, the hazard have been solved or fixed. So when clicking the delete report, by clicking the confirm button, the symbol will be disappeared and the report will also be deleted. Below is the hazard directory log, which contain a reporter name, category, description, location address, coordinates, date and time, and device and source. So on the top, we can search report. So as example, when I search on reporter name called Aceh, it will display what Aceh has been reported. Beside on the search report is the category. So it will filter the category. As example, when I click on environmental, it will only filter the category of environmental hazard. When I click on road, it will only display the road category hazard. The next one is export CSV. I can save the CSV file. So it will display all types of information here. The administrator can review for future analysis or documentation.
So, Assalamualaikum warahmatullahi wabarakatuh and a very good day. My name is YASSER bin Yahya and today I will be explaining to you how the database works and the quality assurance of the application. Now let's take a look at our backend control center. What you see here is the Firebase console, specifically the project overview dashboard for our project. As you can see near the top, we are currently running on Firebase Spark Plan, which is the no-cost tier, making it perfect for our development and testing phases. Just below the project name, you will notice that we have successfully integrated two separate applications into this single Firebase environment. First, we have our Android application. Second, we have our accompanying web application. Bringing both platforms under one Firebase project allows us to share the same Firestore database and analytics data seamlessly. Now let us transition to the Firebase Analytics dashboard for our project. While Firestore handles our data, Google Analytics for Firebase allows us to monitor how users are actually interacting with our mobile application. So focusing on the user activity of a time graph, you will notice the timeline was flat until a very recent sharp spike. We have logged one activity user across the 1 day, 7 day, and 3 day tracking metrics. This perfectly reflects our initial live testing phase, showing that the app is successfully connecting to the cloud and tracking sessions. Over on the right here, the active users in the last 30 minutes naturally sits at 0 as we are not actively running a test session at this exact moment. So if we scroll further down the dashboard, we gain valuable insights into the technical health and user engagement of the application over the last 28 days. So there are 3 key metrics here that demonstrate the success of our build. So over on the right here, for the release status, under the latest app release overview, you can see that version 1.0 of the Android app was deployed with a successful status. So over on the left side here, app stability. This is perhaps the most important metric for our development team. Under the app stability overview, the application is registering 100% crash-free users. So this proves that our implementation of the Google Maps SDK, location permissions, and real-time Firestore synchronization is robust and stable on the Android platform. As for user engagement on the right here, looking at the bottom right, we have an average engagement time per active user of 2 minutes and 4 seconds. This duration indicates that the user had ample time to open the app, allow the map to center on their GPS location, view the hazard markers, and explore the reporting form without the app closing unexpectedly. So in summary, our analytics confirm a stable, successful launch of version 1.0 with seamless back-end tracking. Moving on from the analytics dashboard, let's take a look under the hood at our actual database. What you are seeing here is the Cloud Firestore database for our project. Because Firestore is a NoSQL database, our data is structured into collections and documents rather than traditional tables. So on the far left here, you can see our primary collection named hazards. Every time user submits a report through the mobile app, it creates a new document inside this collection. In the middle column, you can see a list of these auto-generated document IDs. Each ID represents a unique hazard report submitted by a user. So we have currently selected the top document to inspect its contents. So on the right, we have the actual data fields stored within the specific report. This directly aligns with our project requirements for data capture. So you can see the category is log as a road hazard, and the user provided a description stating a tree has fallen down on the road. So for the location data, this app successfully captured the exact GPS coordinates, as you can see, the latitude and longitude, and translated that into a readable user location, which in this case is near your ATM Arau in Perlis. We are also capturing the username, which is Archie, the exact date, time of the report, and the device info and user agent string, showing this was submitted from a Vivo device running Android 15. The Android app serves as the public-facing reporting tool. So when a user spots a hazard, they fill out the form in the app. The app uses Firebase Android SDK to push a new document directly into the hazards collection in Firestore. So the app listens to Firestore in real time. So when a new hazard is added, it pulls the data and draws a colored pin on the Google map. So our HTML web application serves as the administrative control center running directly in the browser. So using HTML for the structure and JavaScript with the Firebase Web SDK, the web page queries the exact same hazard collection. It fetches all the documents and displays them in an organized HTML table for the administrative to review. So data migration, when an admin clicks resolve or delete on a hazard in the web dashboard, the JavaScript code sends an update directly to Firestore to modify that specific document status. So because both independent apps are plugged into the same Firestore database, they stay perfectly synchronized. So to summarize how real-time synchronization is achieved, a user reports a hazard via the Android app. The data is instantly saved to Firestore. The HTML web app via a JavaScript return instantly updates its admin table without the page needing a refresh. So the AMIR resolves the hazard on the HTML web app. Firestore is updated, then the Android map immediately updates, removing the resolve marker. So in this setup, Firebase does all the heavy lifting for data synchronization, allowing our mobile app and HTML web app to work together seamlessly without needing a traditional back-end server.